Welcome to Tanu Science. In this video, we'll learn the problems from chapter 2 of class 10. First one, book back question. An object is placed at a distance 20 cm from a convex lens of focal length 10 cm. Find the image distance and nature of image. So in this question, we have to find the two things. One is image distance, another one is the nature of image. Image distance taken as V. Image may be virtual and erect or real and inverted. Right. What are the data given? Distance of the object given U. So distance of the object always taken as U in negative direction from a convex lens of focal length. So focal length of convex lens is 10 centimeter. This is taken as F. So focal length of convex lens always taken in positive. So the given data U is equal to minus 20 centimeter because this is convex lens. The object placed left to the lens. So the distance between this object and the lens is 20 centimeter. So this is measured left to the lens. So left to the lens in the sense it coincides with the along the x-dash axis. So along the x-dash axis, according to sign convention, we have to take negative. So along the x-dash direction, we have to take the negative sign. So that U is minus 20 centimeter. Then focal length of convex lens F always taken positive. F is equal to plus 10 centimeter. We have to find the image distance V. We know that lens formula. So lens formula 1 by F is equal to 1 by V minus 1 by U. 1 by FL is 10 is equal to 1 by V. We are going to find out minus 1 by UL is minus 20. So that minus 20, then 1 by 10 is equal to 1 by V. It's minus to minus plus. So plus 1 by 20. Then 1 by 10. This 1 by 20 came here means minus 1 by 20 is equal to 1 by V. We have to do the cross product. So 20 minus 10 by 200 is equal to 1 by V. So 20 minus 10 is 10 by 200. Then 1 by V. 0, 0 going to be cancel. So we take reciprocal. V is equal to 20 centimeter. So V is equal to 20 centimeter. This is the image distance formed by this convex lens. So V is equal to plus 20. So V is equal to plus 20. It will be formed behind the lens. So along the x direction. So along the direction, the image will be formed. So if the image is formed behind the lens, it is always real and inverted. So real and inverted 20 centimeter. This distance is 20 centimeter. So nature is real and inverted. This is nature of image. This is image distance. Question number 2. An object of height 3 cm placed at 10 cm from a concave lens of focal length 15 cm. Find the size of the image. This is a concave lens. Focal length of the concave lens is 15 cm. For concave lens, always you have to take the negative sign for focal length minus 15 cm. Object height is 3 cm placed at 10 cm from a concave lens. This is height of the object. So height of the object is given 3 centimeter. Height of the object denoted by h is equal to 3 centimeter. This is above the principal axis. So always you have to take positive sign for height of object. Then at distance of the object 10 centimeter. So this is 10 centimeter. This 10 centimeter left to the lens. So this is taken in the negative sign. So U is equal to minus 10 centimeter by using the sign convention. So left hand side represents x direction. So along the x direction we take negative sign. This height of the object represents in the positive y axis. So in the positive y axis h is taken in the positive value. We have to find the size of image. The size of image is nothing but h dash we have to find out. So we need that formula relation between magnification, focal length and distance of the object. M is equal to F by F plus U, where M is the magnification the ratio of size of the image to the size of the object. H is equal to F, where F value minus 15 divided by F value again minus 15 plus U. U value is according to the question minus 10, and H dash, where H is the height of the object. Here height of the object given plus 3 centimeter. So 3 is equal to minus 15 plus into minus minus. So 15 minus 10 is minus 25. Minus minus cancel. So 3 5s are 15, 5 5s are 25. Then cross product H dash is equal 3 3s are 9 divided by 5. If you divide, size of image will be 1.8 centimeter. This is size of image or height of image. This is the answer. Next, solved problems. Question number 1. Light rays travel from vacuum into a glass whose refractive index is 1.5. If the angle of incidence is 30 degree, calculate the angle of refraction inside the glass. Let us consider this is glass. This is normal line. The incident light rays travels from vacuum to glass. The refractive index of glass is 1.5. If the angle of incidence is 30 degree, according to the question is 30 degree, angle of incidence I is equal to 30 degree. Already we mentioned here the angle of refractive index of glass with respect to vacuum is 1.5. So this is G, and V, refractive index of glass with respect to vacuum, that is mu GV. Now Snell's law we can apply. Mu GV is equal to sin I by sin R. Mu G by mu V is equal to sin I. Angle of incidence is 30 degree. We have to find the angle of refraction R, sin R. So mu G value is 1.5 with respect to vacuum. Mu G value is 1.5 is equal sin 30 is 1 by 2 into sin R. This 2 into 1.5, 3 is equal to 1 by sin R. Then take reciprocal, 1 by 3 is equal sin R. Then R is equal to sin inverse of 1 by 3. R is equal to sin inverse of 0.33. It will be continuing. R is equal to 19.45 degree. This is the answer for angle of refraction. We can complete here itself because no need to memory this answer. Sin inverse of this value is 19.45 degree. Second solved problem. A beam of light passing through a diverging lens of focal length 0.3 meter appeared to be focused at a distance 0.2 meter behind the lens. Find the position of the object. So position is U. That position of the object always in the negative sign because object always placed left to the diverging lens. A diverging lens represents concave lens. So another name of diverging lens is concave lens. The concave lens focal length always taken as negative sign. So F is equal minus 0.3 meter appear to be focused at a distance 0.2 meter. So the distance of image is 0.2 meter. This concave lens always forms image same side of the object. So always forms virtual and direct image. So virtual and direct image always will be the same side of the object. For example, this is object, this will be image. So the image distance is always negative. So V will be here negative. Now we have to find out the U. So formula, we know that lens formula 1 by F is equal 1 by V minus 1 by U. 1 by F value is minus 0.3 is equal to 1 by v value is minus 0.2 minus 1 by u always should be in the negative, already we know that. So this 1 by minus 1 by take this side, this minus 1 by 0.3 send this side. So 1 by u is equal to 1 by 0.3 minus 1 by 0.2. 1 by u is equal to, do the cross product, 0.2 minus 0.2, this minus 0.3 into 0.2, 0.06. 1 by u is equal minus 0.1 by 0.06. For our convenient, multiply with 100 by 100. So 1 by u is equal 0.1 into 100 is minus 10, and 0.06 is 6. If we cancel, we'll get 5 2s are 10, 3 2s are 6. So minus 5 by 3, then do the reciprocal. U is equal to minus 3 by 5. U is equal to, if you simplify this one, minus 0.6 meter. This is distance of object. Solved problem 3. A person with myopia can see objects placed at a distance of 4 meter. So can see distance is x. If he wants to see object at distance of 20 centimeter, so want to see the distance is 20 meter, we have to take as y. What should be the focal length? F we have to find out. Then power of the concave lens he must wear. So P we have to find out for concave lens. For concave lens, F should be in the negative. Then power of the concave lens also should be in the negative. Solution: the right relation to solve this sum, f is equal to xy by x minus y. This x represents can see distance 4 meter. This y represents want to see distance is 20 meter. Now we can substitute in this formula that f value should be in the negative for concave lens. So f is equal to the x value given in question 4 into y they given 20. Then x value is 4 minus y value is 20. F is equal to 420 is 80, then minus 16. If we cancel, F value is minus 5 meter. So F is equal to minus 5 meter. This is focal length of concave lens, because here negative sign is there. Next, in the question they are asking one more thing, power. They are asking the power. So power, we know that power is the reciprocal of focal length. P is equal to 1 by f. Already you know that this is focal length of the concave lens that person should wear. P is equal to 1 by minus 5. This P is equal to minus 1 by 5 is minus 0.2. Unit of power is diopter. This is the power of the concave lens. Solved problem. Question number 4. For a person with hypermetropia, the near point has moved to 1.5 meter. Calculate the focal length of the correction lens in order to make his eyes normal. We know that for normal eye, the near point is 25 centimeter. If you convert into meter, it will be 0.25 meter. This for normal eye. For a person with hypermetropia, the near point is given small letter d is equal to 1.5 meter. So we have to find out the focal length. Focal length of the convex lens, because convex lens is rectifies the hypermetropia, so that f should be in the positive. So normal high, for the normal high, the focal length is f is equal d into d divided by d minus d. This d, we know that person with hypermetropia, the near point distance. This d is the normal high person near point distance. So f is equal to small letter d value is 1.5 into capital D value is 0.25, then capital the small letter t is 1.5 minus capital D is 0.25. F is equal to, if you multiply 1.5 and 0.25, you will get 0.375. Then if you simplify this, you will get 1.25. Then F is equal to 0.3. This everything given in meter, so that F also value is 0.3 meter. This is correction lens in order to make his eyes normal. Thank you, students.